My name is Quinn and I live on the central coast of California. I really like to do embedded electronics, soldering, hacking, 3D printing, and laser cutting. It's really cool seeing your project come to life. I used to do a lot of Lego stuff, like taking things apart, and a computer is something that you can easily take apart and sometimes not as easily put it back together. And so I got an interest in that, and I went to the Maker Fair in San Mateo in 2011 with my dad, and so there I got my first Arduino. This is the Arduino. This is the main board, the Uno, and this is the Make Edition for the Maker Fairs. So here I'm using my phone, and when I text it a certain command, like LED on, then it goes through the internet and comes back to the Arduino. The main thing that's special about this is that you can program it to do whatever you'd like. You can attach sensors such as light sensors and attach it also to LEDs or motors. Everything's open source, which means you can get everything for free online, and one by one I went online and looked at tutorials, and that's how I learned. This is a Weevil eye kit. I used a soldering iron and some solder to solder the kit, and basically solder is electric glue. And so I bond the circuits together using the solder, and thus the wires would be connected inside this board. This could be used as a night light, so when the room is darker, then the lights would turn on, and as it went darker, then the lights would be brighter.
Well, I didn't know anything about the maker movement until I heard about Quinn. And it's pretty fun when you have a gem right there in your own district. It's pretty cool to have a student who's that curious and that into learning on his own, basically.
This is filament. This is a soldering iron. This is a Leatherman. These are solder supplies. These are breadboards. These are Arduinos. And this is my 3D printed logo.
Quinn came to one of our school board meetings, and he talked to the school board about what he does with Arduinos and all those circuit boards and things, and really gave us his thoughts on how we need to be more engaging as a school district. The 3D printer that I have is called a BucoBot. So here's the filament, and it's basically a spool of plastic, and it has the spool holder too. It goes all the way down into here, and this is the main extruder part. And so basically it melts it and it spits it out in the nozzle. This axis is the x-axis, so it moves side to side. This is the y, and right here are the z-axis, and so these move up and down. First, you take your 3D model from tinkercad.com and download it into your host program. Then you slice it using the program called Slicer, and this basically turns the 3D model code into 3D printer code. And so the 3D printer code is basically a set of X, Y, and Z coordinates that my computer tells the 3D printer to do. Layer by layer, it prints a 3D object with filament. The power, I think, of the maker movement is they're really focused on building something that they think is cool. They're not like, well, here's a math problem, you need to learn it. No, here's a cool project, and I want to build that project. Oh, and by the way, I need to learn about electricity and engineering principles. They're learning all these STEM kinds of things that are going to be helpful to them later on, but they're learning it in the context of something that's fun and interesting to them. The hackerspace, I was teaching my friends how to solder, as well as teaching them how to use the tinkercad.com software to design their own keychain and 3D print it. Click on the box and change the one that goes up and down to 5, or actually to 3. I really like to teach other people how to do embedded electronics and Arduino and stuff like that, because once I teach them, they can teach some of their friends, and that overall makes the maker community bigger, and everybody can help each other. Is it working?
Yeah.
Nice.
So I've noticed it looks like that thing always stays in the same place, and then that board moves around it.
Yeah, exactly. So the x-axis is like that, y is like that, and then z is...
I'm interested in this idea of makerspaces finding their way into schools and transforming a number of things. You know, the art studio connected to the computer lab, connected to the shop class, connected to the biotech lab. But the difference is, instead of directing students to do things, you're inviting them to create things and make things.
the self-confidence and sense of self-efficacy that I think students get from creating their own projects and seeing them be successful and seeing that they can do it, that I think is so powerful.
We are defined very much by our culture as consumers, and we're users in that sense. And what I'm trying to really affect is a transition from that mindset to one where you're a maker. The world around me isn't just something that was built for my use, it's something that I need to contribute to, and I could change that. If something isn't the way it should be, I have the power and the sense of control to be able to do that.
I look at everything a lot differently now because now I can see what's in every electronic product, what's in a smartphone, every component in it, as well as what's in a computer. But other things such as skateboards, bicycles, I could see different ways on how to make it better so that other people could iterate on that design.